In this section, the argument focuses on alloy steels. We have already argued that iron without impurities is not practical for machine parts. Then, iron is usually made into steels by adding impurities such as carbon to it. In this process, the important components are carbon, silicon, manganese, phosphorus, and sulfur. They are known as the 5 major additive elements. I have already explained that carbon is the most important among those components. Carbon is the source of strength, hardenability, and other functions of ferrous metals. So, carbon is the essential component in steels. Silicon enhances yield point and tensile strength. Manganese enhances ductility and has properties that make steels easier to be quenched. Phosphorus decreases toughness at low temperature, making steels more brittle in cold weather. Sulfur makes steels brittle at higher temperatures of 900 degrees. Phosphorus and sulfur are harmful substances and should be decreased. Steels are broadly classified into carbon steel and alloy steel. Alloy steels are distinguished from carbon steels by the type of additives. Carbon steels contain the 5 major elements, mainly carbon. Alloy steels contain other additional elements such as chromium, nickel, molybdenum, and tungsten. This classification of carbon and alloy steels has the advantage of facilitating material selection in machine design. Alloy steel is expensive but has excellent properties. These are mainly strength, quenching ability, wear, and corrosion resistance. It is important to understand that alloy steel is used unavoidably when the requirements cannot be met by normal carbon steel. This is because alloy steels are expensive and provided in a small variety of shapes and dimensions. When carbon steel does not meet the strength requirements, we may consider using an alloy steel. This is because they have better quenching property than carbon steel. Quenching property is the variation of the quenching depth based on the material sizes. Normal carbon steels have slower cooling speed, especially with larger size that have larger heat capacity. In other words, quenching does not reach the center of the material. On the contrast, with alloy steel, quenching can reach the center compared to carbon steel. The combination of quenching and tempering can be expected to more improve the strength of alloy steels. Note, however, that the rigidity remains constant. You should firstly be noted with this feature of alloy steel. Stainless steel may be one of the most commonly used alloy steel around us. Stainless steel is a corrosion-resistant alloy steel with the addition of chromium and nickel in addition to the 5 major elements. Chromium is combined with oxygen to form a dense oxide film, which is called passive film. The film covers the metal surface and makes stainless steel rust resistant. Even if stainless steel is scratched, the film is quickly formed and covers the metal surface to prevent rust from progressing. On the other hand, surface treatments on carbon steels may be another option for corrosion resistance. But when it is scratched, rust develops quickly and progresses towards the inside. Considering these features, stainless steel is used in relatively harsh environments, such as sink, where the products are exposed to water and detergents.